Hello friends, myself Pratik. In this session we are going to apply naive-Bayes classifier for a given dataset. Let us start this session. As discussed in our previous session, we can apply naive-Bayes classifier for making a predictions for this new data point X, who is actually a new joinee in our organization. We have to predict whether this new joinee will be commuting to office through two-wheeler or four-wheeler. For this, we have collected the data of 30 instances. Out of this, 20 are labeled as four-wheeler, while 10 are labeled as two-wheeler. It means that these 10 persons are commuting on two-wheeler, while these 20 persons are commuting through four-wheelers based on their salary and age. And in this session, we will be learning how we can apply naive-Bayes classifier to predict the class for this new data point X. And in order to do this, we can apply Bayes theorem for making predictions for this new data point. As discussed in previous session, there are two possible hypotheses. One possibility is that this new data point will belong to class two-wheeler or it will belong to class four-wheeler. For this, we will be calculating the probabilities for each of these hypotheses. It means we have to calculate the probability of two-wheeler given X because X is the instance which is already given, and for this we want to make prediction that whether he or she will be commuting through two-wheeler or not. Same way, we have to find out the probability of second hypothesis, which is probability of four-wheeler given X. So we will be comparing these probabilities, and the class having maximum probability will be considered as winning class. We will be using Bayes theorem to calculate the value of two-wheeler given X or four-wheeler given X. As discussed, in this dataset we have 30 instances, 20 belongs to four-wheeler and 10 belongs to two-wheeler. Now let's first calculate probability of two-wheeler given X. In order to calculate probability of two-wheeler given X, we can apply Bayes theorem, which states that A given B can be calculated by using this formula, which is equal to probability of B given A multiplied by probability of A divided by probability of B. If I apply this theorem for calculating probability of two-wheeler given X, the equation will appear like this. Here, probability of two-wheeler given X will be equal to probability of X given two-wheeler multiplied by probability of two-wheeler divided by probability of X. Here we call probability of two-wheeler as prior probability, while P of X is called as marginal probability. Probability of X given two-wheeler is called as likelihood, while the final value which we will be obtaining after solving this equation is considered as posterior probability. We will be calculating all of these values one by one. The first value we have to compute is probability of two-wheeler, and we calling it as prior probability. In order to calculate the probability of two-wheeler, we have to divide the number of persons commuting through two-wheeler divided by total number of persons. So the number of persons commuting through two-wheeler is 10, while total number of persons are 30. So probability of two-wheeler is 0.33. So we have calculated our prior probability. Now let us calculate marginal probability, which is P of X. Here we are considering an area which is similar to our new data point. So these are the neighborhood of our new data point, and we named this neighborhood as area of marginality. And in order to calculate the probability that data point belongs to this area of marginality, we will be using this formula. That is number of similar observation. In simple words, the number of observation which fall in this area of marginality divided by total number of observations. So as you can see that there are 5 similar observation to this new data point which falls in the area of marginality. So 1, 2, 3, 4, 5. So these are 5 data points. We will not be counting new data point because for this we have to make predictions. So the labeled data points are 5. So there are 5 neighbors or there are 5 instances which are similar to this new data point. and total number of data points are 30. So the marginal probability will be number of similar observation divided by total number of observations, which is 5 divided by 30, and in this case it is 0.166. So we have calculated marginal probability, and I hope that this gives you clear idea why it is called as marginal probability, because we are calculating the probability of data points belonging to the area of marginality. Area of marginality can be considered as area of neighborhood, which is similar to our new data point. And in this area we have 5 instances, while total are 30 instances. So its probability is 5 divided by 30, which is 0.166. So we have calculated second point. Now in next step we have to calculate the probability of likelihood, which is probability of x given two-wheeler. It's very interesting to understand how we are going to calculate this value. So it is probability of x given two-wheeler. Here it is given that the person are commuting through two-wheeler, and we have to find out the probability of x after this. So we only need to focus on the data points which commute through two-wheeler, and then we have to apply this over our area of marginality. So let's first of all only consider the data points which belongs to two-wheeler class. So as shown in this figure, I have removed all the data points of four-wheeler class and highlighting only the data points of two-wheeler class. And the count of these data points is 10. So we can calculate probability of x given two-wheeler by using this formula, which is number of similar observations among those who commute by two-wheeler. So this is very important point. We are considering the number of similar observation among those who commute by two-wheeler, because we are only considering the people who are commuting by two-wheeler, and we have to consider x, which indicates similar observation which belongs to area of marginality. So number of similar observation among those who commute by two-wheeler. So in this area I have only 4 data points, so that number will be 4 divided by total number of two-wheeler observations, which are 10. So its value will be 4 divided by 10, which is 0.4. So the probability of x given two-wheeler will be 0.4. Again, we can understand this. Here we have to consider the number of similar observation among those who commute by two-wheeler. So that's why in first step I have removed all four-wheeler data points, only showing two-wheeler data points. We have to consider number of similar observation who commute by two-wheeler. So in this I have only 4 data points. So it will be 4 divided by total number of two-wheeler observation, that is 4 by 10. So it means its value is 0.4. So we have all our values. Now we can simply use all these calculated value to find out our posterior probability. So let's fit all these values. So the probability of x given two-wheeler is 0.4, while the probability of two-wheeler is 0.33, which will be divided by p of x, which is 0.166. So here we have put all these values, and when I calculated all these values, I got a number 0.80. It means that probability of two-wheeler given x is 0.80. Since this is a binary classifier and we know the probability of our one class, so I can simply calculate the probability of four-wheeler given x by subtracting 0.8 from 1, which is 0.2. It means that probability of two-wheeler given x is 0.8, while probability of four-wheeler given x is 0.20. So we can conclude that the predicted class will be two-wheeler because it has more probability as compared to four-wheeler given x. So this way naive-Bayes classifier will make predictions for this new data point, and in this case the prediction will be two-wheeler. In order to understand it a little bit further how we have performed all the calculations, let's perform the calculations for four-wheeler given x also. So I request all of you to take your pen and notebook and solve the value of probability of four-wheeler given x for the given data set. So I request you to pause this video at this point, and after solving this, you can again play this video to compare your solution with the solution discussed in this video. So let's calculate the probability of four-wheeler given x. And for this, we can apply Bayes theorem. And we know that this will be probability of x given four-wheeler multiplied by probability of four-wheeler divided by p of x. So first we have to calculate probability of four-wheeler, which is very simple to calculate. We have total 20 observations for four-wheeler while there are total 30 instances including both two-wheeler and four-wheeler. So probability of four-wheeler is 20 divided by 30, which is 0.666. So we have calculated our first probability. Next we have to calculate p of x. The logic to calculate p of x will remain same, and we have already calculated its value in our previous case. So let's do this again. P of x is number of similar observation divided by total number of observations. For this we have to consider area of marginality. So let's suppose this is our area of marginality, and in this area I have similar observation to my data point, and these similar observation are 5. So it will be 5 divided by 30, which is 0.166. So we have calculated p of x. Now in third step we have to calculate probability of x given four-wheeler. Now in this case we have to find out the number of similar observation among those who commute by four-wheeler, because four-wheeler is given. So we have to consider all those points which commute by four-wheeler, and we are concerned with number of similar observation in this area of marginality. So let's remove all two-wheeler data points. So we have this. Now in this area of marginality, this is new data point, so we will not be counting this. So we have only one data point which belongs to four-wheeler in this area of marginality. So it will be 1 divided by 20. So number of similar observations among those who commute by four-wheeler is 1, while total number of four-wheeler observation are 20. So it is 1 divided by 20, which is 0.05. So we have calculated all these values. So let's put all these values, which is 0.05 multiplied by 0.666 divided by 0.166. When we solve it, the final value obtained is 0.2. So you can clearly see that the probability of four-wheeler given x is 0.2, while the probability of two-wheeler given x was 0.8. So the predicted class will be two-wheeler. So by using Bayes theorem, we can find out our predicted class. We have performed this for binary classifier, but the same logic can be applied in case of multi-class classifier. I hope this video has given you fair idea about the working principle of NB classifier. Thanks for watching this video.